All right, guys, so we're back with lesson two, and this is a continuance of yesterday's lesson. And also, we did see this lesson. This was the last lesson we saw in person, and this lesson is about quadrantal angles. So, you will need the notes from yesterday's video in front of you at some point in this lesson, and I'll let you know when. And so the objective today is I will be able to find exact trig functions using quadrantal angles. Before I get into what a quadrantal angle even is, let me remind you about something we talked about prior to getting into this part of the unit. So one thing that the unit showed us was we have angles that are made from two different sides. This side here, which is the initial side, and then wherever this side, however high up that goes, that gives us this angle theta here. And this side here is called the terminal side. Let me put that in a different color. That's our terminal side. And so this is the terminal side. So the terminal side is what's important today. And we will get back to that terminal side in a second. Okay, so just some vocab now. Let's get into the definition of a quadrantal angle. So quadrantal angle is basically when the terminal side, so this side here, oops, didn't mean to delete that, meant to highlight that. When this side here lands on one of the axes, right? So our different axes are this side, or this side, or this side, or this side. It's either going to land on an X or a Y axis. And so that's what one of the quadrantal angles, that's what a quadrantal angle is. Now, there are some common quadrantal angles, and I will list those here. One of the common ones is when theta is equal to 0 degrees. So I have my initial side here, and my terminal side also lands here on this axis. So it never actually created an angle measurement because it's 0 degrees. So it's either in 0 degrees or 0 radians. So I'm just going to refer to radians as rad. Okay. The second one is one of the most popular, I would say, that we all know and love. And that is when theta equals 90 degrees. So my initial side is here, and my terminal side again will land on one of the axes. So it lands here on this axis. So from here to here, theta is equal to 90 degrees. Or how many radians is that? So if I actually went through and did the process of converting from radians to degrees or degrees to radians, we would get pi over 2. And so we already know how to do that. Sorry about that. And common quadrantal angle is if our initial side is here and our terminal side is here. So going from here to here is how many degrees? This is a straight line. So how many degrees is a straight line? We know that's 180 degrees. So here's one thing that comes up that we're talking about when we're in person. What about in radians? So do we have time to sit here and convert from degrees to radians every single time? No. So there's a few very important common angle measurements that you might want to remember, because that's the key to some of this, is kind of memorizing which ones are really important. So you don't have to copy this part down. This is just for me to show you real quick. So we said that 90 degrees is pi over 2. So from here to here, From here to here, that's pi over 2. Well, how many pi's are here? Technically, there's an invisible 1 right here. So this is 1 pi over 2. Now, if I continue to go from here to then here, how many pi's would I have at this point here? Well, if this from here to here is 1, then from here to here would have to be 2 pi over 2. But we can see right now that this could be simplified, where this would cancel out, and then just pi is left. So 180 degrees is also pi radians. All right, so the next and final, most common quadrantal angle is, well, if our initial side is here, and we've already gone to 90, 180, well, the next stop is here, and that's at 270 degrees. So 90 plus 90, that's 180 plus another 90. Well, that's 270. Or, now let's think about this for a second. So we said from here to here is 1 pi over 2 radians. From here to here is 2 pi over 2 radians. So how many pi over 2 radians do you think is down here? Well, you should have said 3 pi over 2 radians, or rad. All right, the example. So all they're going to give you is something like this, sine of negative 180 degrees. They're not going to ask for all 6 trig functions. They're only going to ask you for one. But the directions are find the exact value of each trigonometric function if defined. If not defined, write undefined. I'm going to highlight this if defined part. So really quick, what they mean by that is, for instance, let's say that you run into a situation where you have 0 in your denominator. That's not a definite answer. That's undefined. So then your final answer would just be undefined. So let's get into this example here. Step 1, I would say graph. Graph the degree measurement that they give you. Now, the degree measurements that they give you, or the angle measurements that they give you, are all coming from the most common quadrantal angles. And that's from your notes up here. So for this first example, you're like, wait a minute, I didn't see any negative examples up there. But let me remind you that the book says for negative angle measurements, you just move in a clockwise motion to get that angle measurement. So if I start here on my initial side and I move clockwise 180 degrees, I still land here. My terminal side is still here. Okay, so that's negative 180 degrees. That's your step 1. Step 2, locate a or an x, y point on the terminal side. Okay, this is very important, and I'll tell you this. Always use basically 0, a combination of 0 and 1, or 0 and negative 1. So this is my terminal side. Here's a point. The point here is negative 1 comma 0. So my step 2, negative 1 comma 0. That's the point I located. Stick with 1s and stick with 0s. Step 3. All right, so step 3 is to calculate R, R if needed. So what trig function are we dealing with here? Well, I want to know what sine is. So let's go back to yesterday's notes And yesterday's notes, we said that sine of theta is equal to y over r. I don't care about anything else but this here for this example. So let me go back and let me remind myself that sine of theta, I'm just writing here, sine of theta is equal to, oh my gosh, what was it equal to? Totally forgot. Y over r is equal to y over r. Okay, I'm going to get back to that in a second. So I have a y because that point that I located, x, y. So I know for sure that 0 is going to end up being plugged in here. But what's my r? So that's where step 3 comes to play. So calculate r if needed. So yesterday we said that r is equal to x squared plus y, x squared plus y squared. So we plug in our numbers here. And we said x is -1 and y is 0. These numbers came from step 2. All right. So let's continue here. R is equal to, well, what's -1 squared? That's 1. 0 squared, that's 0. 1 plus 0, 1. Square root of 1, 1. So your R is equal to 1. So we have the whole gang here. So step 4. Finalize your answer. Tell me what is, so calculate your trig function. All right, so I know that I just like to list everybody out here. X is equal to -1, y is equal to 0, and r is equal to 1. Do I need to use all these three? No, because sine of theta, well, not theta, we have a degree measurement, that's -180. So sine of -180 degrees is equal to y over r. My y is 0, my r is 1. Simplify. So what's 0 divided by 1? Well, that's 0. So this is my final answer. Here's the second example. So I'm going to follow the same steps from up here. 1, graph this. Until you totally memorize the graphs, then yes, the answer is you do need to graph it every time. Those of you who are already asking, do I have to graph it every time? Right now, the answer is yes. All right, so 3 pi over 2. Well, how do I graph 3 pi over 2? Well, come up here to the common ones. 3 pi over 2, that's like example number 4 here. You see that here. So that's going to look like that down here. So it goes from here to down here. And this is theta equal to 3 pi over 2. Now, second step says locate an x and y point on the terminal side. So locate a point here. Again, like I said, this is your terminal side here, where the arrow is at. Now locate a point. Use the very first point here. This point right here is 0, -1. So like I said, you're going to continue to use combinations of zeros and ones. It just depends on where you land on your axes. So that's step 2. Step 3, calculate r if needed. Well, do I need to calculate r? Well, I have 0, -1. This is my x. This is my y. How do you know if you need to calculate r for step 3? Well, that depends. What is tangent theta equal to? Well, let me go back to my notes from yesterday. We said that tangent of theta, that's this one here, is equal to y over x. Do I need my r? No. Tangent of theta is equal to, tangent of theta is equal to y over x. You don't need to calculate for r. You don't need step 3 in this case. So just plug in. We are dealing with tangent of 3 pi over 2. Your y is -1. Your x is 0. Well, what did we run into here? We have a situation here. We have a 0 in my denominator. So is this defined? No. So your final solution for this one is undefined. All right, so here's your classwork. Make sure that you turn this into Schoology, upload it again, and you'll receive credit. Just try your best. I'm not looking for you to be correct. I just want you to try the problems. Just a little quick tip for number 2. Oh my God, I didn't mean to erase that, meant to highlight that. For number 2, I know it says cotangent. Don't freak out. Go to your notes from yesterday again. Locate cotangent. And this is what it should be. X over Y. So don't forget with those. And that's about it for today's video. See you guys on the next one.